All right. So, hello and welcome everyone. I hope I'm audible to all of you. So, welcome back to this particular channel of Pradhan Academy, right? So, we are back again with the today's topic of differential equations. So, we will discuss about the previous year questions from the topic of differential equation, right? So, we already started this particular series a long time ago, and we had been discussing about the different topics of maths, and in each of the topics, we are basically revising the previous year questions, right? So I hope this particular series has been useful to all of you, right? Please let me know in the comment section. Please let me know in the comments. All right, in the live chat, please give me a thumbs up so that we can start the class. All right. So if you're into this particular channel, I would like to tell you that we have been discussing this particular thing, especially for the JEE mains second attempt, right? So I hope this particular series of lectures has been useful to all of you, and the students who are going to give the JEE mains second attempt in the upcoming days. This is going to be really useful, okay? Because the topic of differential equation is very simple. The topic of differential equation is very simple, as well as coding, okay? So make sure that if you are going for your second attempt paper, so please make sure that you recall and revise this particular content before you are going from your second attempt. Is this clear to all of you? All right. And if you are still new to this particular channel, I would like to say you that you can watch all the previous sessions that I have taken so far in the live tab. Okay. So you go to the channel, you check out the channel, go to the live section, and under that you will find out all the content that has been taken so far. Okay. And you will find out that I have already finished up with this particular session. I will be finishing the calculus, right? So I have done a lot of contents for all of you for basically your practice as well as for your revision purpose, right? So I hope this has been helpful to all of you. Okay. So now today our agenda is basically to discuss the previous year questions, especially from the chapter of differential equation. And if you are new to this particular chapter of differential equation, I would say tell you that please recall this particular chapter by studying your NCRT. Please do your NCRT, and after that, please practice your NCRT exemplar. Please practice your NCRT exemplar questions. Now, this is going to be really important and helpful for all of you. Okay. Now, after you're done with these particular solutions, then you will jump on this previous year question solutions. Okay. This is going to be really useful to all of you. All right. So with this, let's get started. And also one more thing, please don't forget to make short notes before you are going for your exam, because that short notes is going to help you in quick revision. Okay, this short notes is going to help you in quick revision. So with this, let's get started. So today our goal is to discuss the concepts regarding the differential equation. Now, and we are also going to see the most high priority topic that is basically being asked in the differential equation, that is the first order linear differential equation. And the solution of the first order linear differential equation is very important for all of you, right? And we're going to discuss the previous year questions of JEE mains, both MCQ and numerical types, as well as we are going to see and understand what are the types of questions that has been already been asked in the JEE advance. Is this clear to all of you? And also with that, we're going to do some kind of paper analysis. Okay. So if you look at the weightage of this particular chapter, then I can tell the weightage is something around 1 or 2 questions. Okay. So if you look at different papers of each year, the weightage is generally around 1 or 2 question. Okay. Is generally around 1 and 2 questions. Okay. So if you are all right, 1 or 2 questions, something like that. Okay. So 1 or 2 questions will be basically coming out for this particular chapter. Okay. So that basically makes the chapter, since the chapter is very small chapter, once you understand the solution of the differential equation and how to solve for the differential equation, the chapter is very simple. So I can say that if you study this particular concepts and revise this concept nicely, then this is going to be really helpful for your upcoming paper. Okay. And you're definitely going to get the full marks in this particular chapter. Okay. So with this makes a very ideal choice for all of the students, and therefore we will be starting to proceed with the concepts as well as questions. Okay. So here we start with the very first question on our screen. So if you look at this particular problem, now generally whenever you see the solution of differential equation, the mostly if you look at the paper, and if you do a analysis of all the papers that has been asked so far, then you will find out that the first order linear differential equation is the most favorite pattern of question for the examiner. Okay, so especially if you revise this first order differential equation, it is going to be very useful for all of you. Okay, first order linear differential equation. Okay, this is very useful for all of you. This is clear. So we have been the given differential equation as dy upon dx plus tan x times of y is equals to 2 plus sec x divided by 1 plus 2 sec x whole square of it. And it is given that x is basically lying between minus pi by 2 to pi by 2. X is basically lying between minus pi by 2 to pi by 2. I hope this is clear. All right. So now, and for getting the value of the constant for the solution of the differential equation, one boundary value, one initial value is given. So I won't call it an initial value. One value is given, that is basically called as f of pi by 3 is basically given as root 3 by 10. Okay. So this particular value is given, and we have to predict for the function value at pi by 4, and we have to predict the function value at pi by 4. So how are we going to proceed with this question? So let me tell you and let me recall the concept of linear differential equation of first order. So whenever you see a differential equation of this particular form, dy by dx plus some function of x into y is equals to some function of x, and here only function of x, then this kind of equation or this kind of differential equation is called as a linear first order differential equation. Is this clear to all of you? Alright, now the solution to this differential equation is very simple. We have to first find out a integrating factor, and that is basically e to the power integration of px dx. And once you get this integrating factor, the solution is y into integrating factor is equal to integration of integrating factor into q of x, okay, dx plus of c. So once you do this particular, once you find out the integrating factor, the question is very simple. So let us go with that particular process and let us try to find out the integrating factor. Okay, so let us try to find out the integrating factor over here. So how do we find out the integrating factor? Right, it is very simple. We just have to, so let us proceed over here. So the integrating factor is basically e to the power. Now as per the question, our p of x is basically given as tan x. So integration of tan x dx, right? Now we have to basically integrate tan x dx, and that is going to be the integrating factor, right? So let us try to find it out. So from here, so therefore this is going to be equal to, so the integration of tan x, so the integration of tan x is very simple. It is basically natural log of sec x, natural log of sec x. So therefore it is going to be e to the power natural log of sec x, right? And which you can write it as, so we'll just do the base changing formula over here. So it is basically equal to sec x, right? So that is our integrating factor. So therefore the solution is y into sec x is equals to integration of, now the q of x is given as 2 plus sec x divided by 1 plus 2 times of sec x whole square of it into integrating factor, that is basically given as sec x dx, right? Now we just have to integrate this. So this is basically, I can simplify this and write it as 2 times of cos x plus 1 divided by cos x plus 2 whole square of it, right? And then I will have a dx over here. I just changed this sec x as 1 upon cos x, and I just simplified it, and I found out the solution as this. Okay, now what I'm going to do is that, now there is a very interesting step that I'm going to do over here, is that now let us assume the cos x in terms of 1 minus t square by 1 plus t square. Now there is a reason for doing this. Now you can always proceed with this question with the normal procedural way, but I am doing in a some slightly different order. Okay, some slightly different way. So if you do this, you'll find out this. So you will differentiate both the sides, and you will get that this minus of sin x dx is basically equals to differentiation of this and this particular term. So if you just differentiate this, is going to be 1 plus t square and whole square of it, right? So I know you can do this particular differentiation by yourself, right? And this is going to be equal to minus, so I have no space over here, I'm doing it above. So minus of 1 minus t square into 2t. Now you will found out that this 2t cube is going to cancel out, and similarly this 2t minus of 2t and this minus of 2t is going to add up, and that's going to give you minus of 4t, right? So if you do the simplification, and therefore now once you get cos x is basically 1 minus t square by 1 plus t square. So from there you can easily find out sin x is basically 2t upon 1 plus t square. So therefore this format is going to be simply off. So therefore you can change your dx as simply as 2 times of dt. I hope this step is clear to all of you. Now I did some kind of different manipulation. Okay, now this manipulation is basically related to the trigonometry. So if you recall that cos of 2 theta can be written in terms of tan theta as well, right? So that is what I'm doing it over here. All right, so it is basically half angle formula, and how you are better with the trigonometry part, that is totally up to you. Okay, now you can solve this question by the normal way by doing substitution also, but I did it in a simple different way, right? And if you put it back over here, then this particular integration going to change out as integration of 3 minus t square divided by t square plus 3 and whole square of it and dt, right? And therefore this integration is very simple in terms that if I take t common, so if I have to do simple manipulation, that is t plus 3 upon t is going to come out as u, and from there if you differentiate both the side and you put the solution, the solution will be going to come out as y into sec x is basically going to equal to 2 by u plus of c. Now I have jumped a lot of steps. Now this step jump is basically because you have already studied the chapter of differential the integration. So these particular steps must be clear to all of you, right? These particular steps must be clear to all of you. So I'm just using the steps and I'm following the steps directly, right? And then you stuff it back with a t, and then from t to cos x, right? So ultimately your solution is going to look like, so I am erasing this part of the calculations over here. All right, so ultimately your solution is going to look like y into sec x is equals to 2 divided by, now in place of t, so what is basically t? T is basically tan of x by 2, because I have changed in half angle formula, right? So tan of x by 2 plus 1, so plus 3 upon tan of x by 2, this part plus some constant. So I'm just going to put in the value of x as pi by 3, and the value of y will be equals to, so let us check the problem. So value of y is basically equals to root 3 by 10, right? So from this part you are going to get the value of the constant, and that constant is going to come out as 0. So once you get this particular solution of the differential equation, the constant is going to come out as 0, and therefore you have to find the value of pi by 4. So now you have to put the value of x is equal to pi by 4 and find out the corresponding value of y. So from there, if you just do the simplification by yourself, you are going to get the answer of that f of pi by 4 is going to come out as 4 minus square root 2 by 14. 4 minus square root 2 by 14, which is basically going to be equal to option number B, and that is going to be the correct answer to this particular problem. I hope this particular problem is clear to all of you. Is this clear to all of you? Is this part clear to all of you? Please let me know. Right? Even if you have any questions, don't be ashamed to ask that question. Okay, we are all learning. Okay, so there is nothing we think of an ashame. All right, I hope this is clear to all of you, right? So once we are clear with this particular part, shall we proceed with the next problem? All right, I hope you are getting the answer as option number B from this particular problem. Is this part clear to all of you? Is this part clear to all of you? All right, that's great if you are able to get it. Otherwise, you can tell me, okay? And if you're watching the session after the live class is over, you can always put your questions in the comment section, okay? And don't forget to join the Telegram channel from the link in the description. All right. So I will be looking for answering your questions, okay? All right. So let's proceed with the next problem. Let's move to the next problem. So the next problem, if you look it again, it is a problem where we have to basically try to find the differential equation is given in a broader manner, okay, or in a like a difficult manner. So from there you have to basically find it out, that particular differential equation to that kind of a first order linear differential equation, right? So there is some kind of simplification that is to be done over here, and with the simplification you will be finding out that this particular differential equation can be given in the form of a linear differential equation. So let us see how we can do that, right? So let us see how we proceed with this question. So what I'm going to do is over here, I'm going to club the dy and dx term together. So this dy by dx multiplied with, that is given with cos x into natural log of cos x whole square, natural log of cos x whole square, right? This log times whole square, okay? And plus of, so I'm taking the sign on this particular side because it is the only term which is considering only the function of x without any multiplication function of y, right? So I will keep 3y times of sin x into log of cos x. Now don't be afraid to look at this particular expression. It is just given for the sake of simplicity only. Okay, is equals to minus of sin x, right? And therefore from here, if you just try to simplify it further, you can write this dy by dx. What I'm doing, I'm just dividing this particular part. Okay, so dy by dx minus 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 3y times of into tan x divided by natural log of sec x, and basically it is given equals to tan x minus of tan x divided by natural log of cos x and whole square of it. So therefore now you can understand that this is basically a format of linear differential equation of first order. Okay, I did make a sign mistake. Okay, or did I? Oh yes, because I converted this into sec x, so there should be a plus over here because this log of cos x is basically term converted into log of sec x, and that is minus of log of sec x. So therefore that minus minus get can cancel that plus sign. Okay, so from here we can find out easily the integrating factor is basically going to be e to the power integration of 3 times of tan x divided by natural log of sec x, right? And dx over here, and therefore this is very simple because we know if we take natural log of sec x, it is going to be equal to 3 tan x, right? So this is basically, if you take t, this is going to be equal to, dt, right? So therefore from here the integrating factor is going to come out as natural log of sec x whole cube. Okay, natural log of sec x whole cube. I hope this is clear. Or what is basically done is that I have just assumed this substitution over here. Okay, so from here, the solution to the differential equation is going to be y into integrating factor, that is basically natural log of sec x whole cube of it, is equals to given as minus integration of tan x divided by natural log of sec x. So I'm just changing it into natural log of sec x. Okay, so that square is there, so therefore it doesn't make change of sign. So and square of it, and then multiplied with natural log of sec x and whole cube of it. Okay, and we just have to integrate this, right? So we have to integrate this expression in order to get to the solution. So therefore the solution is going to look like y into natural log of sec x whole cube of it is equals to minus of half times natural log of sec x and whole square of it. We are very simple integration. It's just you assume this natural log of sec x as t. So if you do assume this natural log of sec x, so first of all you just cancel out this particular part. So there is going to be 1 natural log of sec x. Now if you assume that as t, therefore differentiation of natural log of sec x is going to come out as, so if you use a dy dx of natural log of sec x, it is going to come out simply as tan x, right? It is going to simply come out as tan x, right? So therefore if you consider this t, it is going to be dt. So therefore from there I am just simply writing this expression plus some constant c. Now for finding the value of the constant, we have provided the value that y of pi by 4 is equals to minus of natural log 2. So from there I will get the value. So x equals to pi by 4, y is equal to 1 upon natural log of 2. So from that particular given condition, the value of the constant is equals to 0. The value of this constant is equals to 0. Therefore, the required differential equation is basically y into natural log of sec x whole cube is equals to minus 1 upon 2 natural log of sec x and whole square of it, right? That is going to be the solution. Therefore we have to find the value at x is equal to pi by 6. So value of y at x equals to pi by 6. Therefore, by putting x is equal to pi by 6 over here, I will get the value of y as, I'll get the value of y as 1 upon 2 times of natural log of root 3 by 2. And therefore, if you simplify this part out, it is going to be 1 upon natural log 3 minus natural log 4. I hope this is clear to all of you. I hope this is clear to all of you. So from this, we are going to get the solution to this particular problem as simple as 1 upon natural log of 3 minus natural log of 4. That is option number D, which is going to be the correct answer for this particular problem. Right? I hope this is clear to all of you. I hope this particular part is clear to all of you. Is this clear to all of you? Is this part clear to all of you? Please let me know. Right. It's a very simple differential equation. Just we converted that differential equation into the format of a first order linear differential equation. And once we are able to convert it into first order linear differential equation, the solution is very, very simple. We just need to differentiate. We just need to use the integrating factor. From the integrating factor, we get the solution. Right. So it is very important to understand and learn the first order linear differential equation because it is very, very useful. And you can see the weightage of this particular topic is very, very high. So if you look at the previous paper, you can see the most of the questions are basically from the first order linear differential equation. All right, but that doesn't stop us from studying the other differential equations, right? So please don't be in the dilemma that I said that first order differential equation is important. That doesn't mean you will leave all the other equations, okay? But if you have to prepare for the quick time, then I would say please prepare the first order differential equation. That is going to fetch you a lot of marks. Is this clear to all of you? Is this part clear to all of you? Right? Please let me know if you have any questions. Please let me know if you have any questions. So in case you have a question, you can always put that in the live chat as well. Okay. All right. Let's work on the next problem. Let's move to the next problem. So next problem is a very interesting problem in terms that you are not given the question directly. You are not given the question directly in the differential equation directly. Rather, you are given an integral equation. So the integral equation, as you can see, so the integral equation, as you can see, it is given as integral from 0 to x t into f of t dt, t into f of t dt is basically given as x square into f of x, x square into f of x for all x greater than 0, for all x greater than 0. And it is said that we have to basically find out the value at f x is equal to 6. So we know the value at a one particular point, that is f of 2 is given as 3. Right. So what are we going to look whenever we have a different integral equation? So first and foremost thing that whenever a variable limit comes in the differential equation, the very first thought that comes to my mind is basically, first of all, differentiate these both sides. Okay. Differentiate the equation both the sides. Equation on both sides. Okay. Differentiate the equation on the both the sides. And if you differentiate the equation on both the sides, the solution you're going to get it as. So I am just going to use the Newton-Leibniz rule. I hope you recall the Newton-Leibniz rule from the application of derivative part, right? So that is basically going to be x into f of x into 1. 1 is basically because differentiation of x, right? Minus 0 is equals to x square into f dash of x plus 2x into f of x, right? That is going to be the required differential equation. And from here, what you can see that your f dash of x is going to, so it is like f dash of x by f of x is equals to minus of 1 upon x is equals to minus of 1 upon x. What I'm doing basically cancelling out 1x. Okay, because x is given as greater than 0. So it is not equal to 0. So I can cancel out from the entire equation. And therefore, I'm left out getting the differential equation kind of this, right? Now it is very simple to do this. Just integrate both the sides. Just integrate both the sides. So if you just integrate both the sides, the solution you're going to get as, so if you consider f of x as t, then f dash of x is going to be dt, right? With respect to dx, I'm integrating. So this is going to give you solution of natural log of f of x is equals to minus natural log of x plus c, minus natural log of x plus c. So from here, what you can see that if you just simplify it out, so f of x is going to come out as c upon some x. So it is something like an rectangular hyperbola. So it is something like rectangular hyperbola. Now f of 2 is basically given as 3. F of 2 is basically given as 3. So C is basically equals to, so C is basically equals to 6. So C is basically given as 6. So once we get the value of the constant, and therefore the only task is basically to find out the value at f of 6. So value at f of 6 is just by putting it over here, it is going to be equal to 1. It is going to be equal to 1. So from here, option number A is going to be the correct answer to this particular problem. I hope this is clear to all of you, right? Is this part clear to all of you? Is this part clear to all of you? Fine. I hope you are also getting able to do this particular problem, and I hope you are also getting the same answer as option number A as the correct answer. Option number A as the correct answer. Is this part clear? Is this part clear to all of you? All right. The question was very, very simple. We just need to integrate once we get a differential equation, and in order to get the differential equation, we just have to differentiate both the sides because we have a variable definite integral, right? So whenever you see a variable definite integral or integral expression is given, the best way to solve the integral expression to get to the differential equation is basically do not differentiation. Just differentiate both the sides. Okay, just differentiate both the sides. Is this clear to all of you? Is this part clear to all of you? Just differentiate both the sides and you will get the solution. Just differentiate both the sides, and the thing is very simple. All right. So I hope this part is clear to all of you. So let's proceed with the next problem then. So let's proceed with the next problem. Now we have the next problem, which is very interesting problem. The next problem is very interesting. So if you look at the differential equation, let me try to form the differential equation first of all. So I'm trying to bring the dy and dx term one side. So it is basically 1 plus x squared plus xy is equals to 5x into square root of 5x into square root of 1 plus x square. 5x square into square root of 1 plus x square. Right. So once we get the differential equation in this form, it is very easy to change it into the first order linear differential equation. Dy by dx plus x by 1 upon x square into y is equals to 5x square divided by square root of 1 upon x square. I just simply divided by this particular expression so as to make the coefficient of dy by dx as 1. I hope this is clear. Now, from here, the solution to the problem is very, very simple. I would request all of you to please try to solve this and let me know the answer. So I hope you can know by now, you must have know how to solve this particular solution from here, right? So once we have the first order differential equation, it is very simple. Just find the integrating factor, and the solution is y into integrating factor is equal to integration of the q of x into integrating factor dx, right? That's the solution. That's the solution. Please try it out. Please try to solve this. Please try to solve this part. Please try to solve this part and let me know the solution. So I'm going to live chats. Please let me know if you have any questions. I hope you are able to solve this from here. It is very simple from here, right? Just take up the integrating factor. Just try to take the integrating factor from here, and the solution is very, very simple. Just try to take the integrating factor from here, and the solution is very, very simple. Is this part clear? Is this part clear to all of you? Okay, so let's proceed with the question. So let's try to solve it. So from here, if you try to solve it further, first of all, let us try to find out the integrating factor. So that is going to be e to the power integration of x upon 1 plus x squared dx, right? Now it's very simple integration. Just consider this as t, and this particular part is going to be dt by 2. dt by 2. So this is going to be coming out as e to the power natural log of natural log of 1 plus x square and 1 upon 2 is there. So this is going to simply come out as square root of 1 plus x square, square root of 1 plus x square. So therefore the solution is basically y into integrating factor, that is this, and is equal to integration of 5x divided by square root of 1 plus x square into square root of 1 plus x square over here. So this is going to cancel out, and therefore ultimately the solution is going to come out as 5x cubed by 3, 5x cubed by 3 plus some constant c. Right. So we got the solution of the differential equation, and we just need to put for the values of the y0 is equal to 0. Y at x equal to 0 is 0. So from there you will get the value of constant. From there you will get the value of constant is equal to 0. Right. And therefore we have to find for the value at x equals to root 3. We have to find for the value at x equals to root 3. So if you put the value at x equal to root 3, the value is going to come out as 5 root 3 upon 2. 5 root 3 upon 2. Is this part clear? 5 root 3 upon 2. Okay. So with this, the solution to this particular problem is going to be option number A over here. I hope this part is clear to all of you. Right. I hope this part is clear to all of you. Please let me know if this part is clear or not. Please let me know this part is clear or not. Is this part clear to all of you? Are you all getting the answer as option number A? So again, you can see there are a lot of questions which are just focusing on the first order linear differential equation, right? Lots and lots of equation only on linear differential equation. So that basically makes this particular topic of linear differential equation the one of the most important. And to be very honest, even if you go to the university, most of the cases also again you are going to solve the linear differential equation in some of the important in like questions of like so if I get a simple example in mechanical engineering, or maybe when you do basically first order wave solutions, okay, like the boundary conditions or like the Moore's boundary condition of the wave absorption, there also you're going to basically use this kind of condition, right? But when you go to the college, you're not going to look at the analytical solution of the differential equation, right? Rather, what you're going to try to find out is that not all differential equation has a solution to it. So what we are going to do, we are going to apply the differential equation solution with the help of some numerical schemes. So we are going to build some numerical schemes later on in the university discussion, okay? But for this particular solutions, we are basically having analytical solution directly, right? So therefore, this is what you are going to study till the class 12 level, and once you go to the university, you are going to study in much depth, and you are also going to discuss about the numerical schemes that has applied to the differential equation solutions, okay? So that's a very interesting study, and the differential equation is basically just a starting, because ultimately all the engineering you are going to do, all the physics you are going to do, you are ultimately going to solve the differential equation itself. Okay, so there will be a differential equation which you are going to solve for the unknown values with the given input, right? Is this clear to all of you? Is this part clear to all of you? So let's proceed with the next problem. Let's move to the next problem. The next problem is again very interesting problem. Now these problems, for solving these problems, it is very important to have an idea of a important parameter that is called as the exact derivative, so d of x by y is basically given as x into dy minus y into dx divided by y square. So what I'm going to do over here is that I'm going to write it as y dy is equals to, so what I'm going to do is that I'm writing as y, I'm multiplying this dy over here, so I'm writing it as x dy minus of y dx, and let us now divide by y square. Therefore we are going to get a simple difference. So I have forgot to miss out this sign of x by y, okay? So I am going to get out a simple differential equation form, that is basically dy upon y is basically given as d of x upon y into the function of sine of x upon y, right? So interestingly, what you are seeing that it's a very question of the variable separable form. So dy by y is basically given as is equals to sine of x by y into d of x by y. So just integrate both the sides and you will get the solution. Um, so just a mistake, okay? Just a small mistake is that I forgot to. There should be minus over here, okay? Just a small mistake. It's minus over here and plus over here, because y into dx, first the y into differentiation of numerator minus numerator into differentiation of denominator. That is the form, right? So this is going to be plus over here. So if I put a minus over here, I just have to put a minus outside the bracket, right? So this minus of x by y. Okay. So over here also it will come out as it will come out as minus of x by y. I hope you are able to understand this. So just integrate both the sides. So you're going to get the solution as natural log of y is equals to cos of x by y, cos of x by y. I'm just incorporating minus sign outside, and this integration of sign is basically minus of cos. So the minus minus get plus, and some constant c. Now it is said that x at y is equal to 1 is given as pi by 2, right? X of 1 is given as pi by 2, right? X of 1 is given as pi by 2. So we basically have to find out. So here the solution is like x is equal to x of y, x is equal to x of y. So if you are putting the value of y is equal to 1, I'm getting the value of x as pi by 2. So I'm just going to do the same thing over here, and ultimately I will see that the value of the constant is going to come out as 0. The value of the constant is going to come out as 0. Now, once you get this functional form where the constant is 0, this is our solution of the differential equation. And now we have to find the value of x at y is equal to 2. So if I just do this following calculation, then the solution of this cos of x by x of 2 is going to come out as 2 times of natural log of 2 whole square minus of 1, and that is going to be option number D, as you can see from this particular solution. So with this, your answer number, option number D, is going to be the correct answer to this particular problem. I hope this is clear to all of you. I hope this is clear to all of you. Right? Is this part clear? Is this part clear to all of you? ये MD आराजू, क्या हल है भैया? या बढ़िया हूँ मैं. Okay. Is this clear? Is this clear to all of you? Right? So with this part, I'm going to give you some homework problems. So some of the homework problems I have left it out over here in this particular PPT as well. Okay. Now to get to the access to the lecture material, you have to join the Telegram channel. So please join the Telegram channel. The link is in the description. Okay. So try to take a screenshot of this and please solve this question and let me know the answer you're getting in the comment section. So I will be looking for your comments. Okay. So with this, I come to the end of the today's session of discussion of differential equation, and that is going to be the end of this portion of the calculus. So I hope you have enjoyed the sessions of these lectures that I have taken so far on the topic of calculus. So with this part, you're going to do better, and help this particular contents must be very helpful for your revision as well. Okay. So I'm assuming that you have taken the full benefit of this particular sessions and lectures. So with this, I wish you all the best for your upcoming examinations.